Hey, it's Random Code here, and today I want to showcase a visualization of Simplex noise, and this visualization is going to be built with JavaFX. But first of all, where did we even get this Simplex noise? So I haven't created all this code myself, but I found a GitHub profile where we can access a version, at least, of Simplex noise, which have been put onto the public domain. See here, this code was placed on the public domain by its original author, Stefan Gustafsson. You may use it as you see fit, but attribution is appreciated. So we're very grateful that he put this into the public domain because it's actually very interesting. I personally do not understand all the mathematics behind it, but we're doing a lot of calculations, a lot of permutations, 2D and in 3D in this case. And it's actually also possible in 4D, but I'm just going to be looking at it in 3D. So how we look at it in 3D is simply that we, with this setup, create a 2D map like this, and I then have some squares, and then for each square there are going to be a value between -1 and 1. If the value is less than 0.1 in my case, for example, I decided to make them white. Otherwise, if they're larger than 0.1 and if they are between 0.1 and 1, they're going to be grayscaled. As you can see here, so we can kind of see the values where the blacker they are, the closer we are to 1. And we're then creating kind of like a slice of a 3-dimensional noise, and then for each slice I'm changing the C value, as you can see down here, and we then have a different noise level kinda, but as you can see it's not completely random. We're kinda following the structure each level, and because we're going through this, I don't know if you can imagine kinda like a 3-dimensional object, then just looking at one slice at a time. Not maybe completely different, but each slice is kinda dependent or similar to the previous ones. As you can see, we're moving around a bit, and I just did it for like I think 6 permutations, but that is a simple visualization, JavaFX, and how it's actually drawn or done. It's actually not that complicated, but what we're simply doing is we have this Simplex noise where we've input an X and Y and a Z coordinate, and then returns a noise level for that specific position. I then simply just take in this case, my JavaFX anchor pane, and kind of separate it into different areas. And then for each area, I just simply give it the coordinate of this area, and then it returns a value. I then simply just set my fill color of a rectangle. So I go through kind of like size of my anchor pane, and I then draw a bunch of rectangles, and set the rectangle to a fill color based on its position, and then the return value from my Simplex noise. So that is what I'm doing inside this update noise method. I then, to actually make this animation, use a timeline where we have a new timeline that the keyframe, so every 0.1 second, we update our anchor pane by simply doing first clearing it, then format our input values, so they're going to be our set values, and we then just simply make sure that they're formatted to only have 2 decimals, because sometimes we get some weird numbers because of the way we are saving doubles in code. So sometimes we might not get just, for example, I think 0.06 is going to be 0.059999. So we just make sure it's only 2 decimals, make the calculations a bit faster. We then simply update our noise based on our C level, and we then in this case just print the console which C level we are on. And we then get this, I think, quite amazing visualization where we can see kind of each slice and how they change. And I think it's very interesting that we are able to create this noise method, noise algorithm, that creates this more or less organic structure where we can clearly see that it kind of grows more or less. And it's actually very interesting that we're able to do this, and it's not that complicated. Some of the math seems to be a bit complicated, but that's where it's amazing that nowadays we can go onto GitHub and find quite a few projects that have been put in the public domain, and we will use this in a small game to create some kind of procedural generated map, for example. So this was my visualization of Simplex noise in 3D. So if you enjoyed my quick showcase of Simplex noise in 3D built with JavaFX, please leave a like and subscribe, and I wish you all a wonderful day.